and thank you everybody for coming. As Rutger was saying, it's actually very exciting for me to wear two hats because it's really helpful when you talk about blockchain and DLT. Because on one hand side, I'm a co-founder of Crypto Valley Association, and we started the Crypto Valley Association to really represent all the people, all the ideas in Switzerland, starting with Zug and then essentially growing across Switzerland itself, because there's lots and lots of innovation, lots of energy, and obviously lots of ICOs that go in our way, right? So, and you can imagine that for a small town of Zug, having every day few teams come over and pitch their ICOs and raising millions of dollars is very as exciting as it gets in Switzerland. So that's very interesting. And you get sort of exposure to that energy, to those ideas, good and bad, and you get to talk to politicians, you get to talk to lawyers, to legislators and regulators. So there's a lot of learnings that you can take from there. At the same time, on the private side of things, as I'm a global CTO at a company that does a lot of software development for banks, for automotive companies, and so on and so forth, people also excited digital transformation and of course want to apply blockchain to everything. And so I kind of combine learnings from both worlds, and this is what I wanted to share with you today when I talk about identity. So my talk, it talks like from theory to practice, and you should take it with a bit of grain of salt because we're all still learning, right? It's not like we all have recipes that are guaranteed to give you success and guaranteed to give you bug-free software and performance. So I thought that, well, I'll structure my talk about three different parts. I'll start at the high level, just hopefully giving you tools to think about building decentralized systems, how to do that, how to avoid making some maybe conclusions that are not deeply thought through. Then talk about identity and foundations and bits and bytes, and then going back up to give you some more tools and give you some examples of applications and how they can be realized. So I'll start with this. I still really like this picture from The Economist. I think they did a good job of, building the hype, which is good on one hand side and not so good on the other hand side because people get ideas wrong, right? People talk about trust and how everything is going to be disrupted and changed, and therefore things start to sound sort of mystical, right? Some, magical, right? It's not magic, it is not a lot of mysticism, even though I'm still puzzled how Ethereum Foundation ended up in Zug, so I will find that out someday. But if we look at decentralized distributed ledger technology, also known as blockchain, it's really built on foundation that existed before, right? A long time. Now there's some interesting papers that talk about academic pedigree and all the forgotten ideas, how you combine these things together. But essentially, when you think about building decentralized system that supposedly, change the economy and solve a lot of problems, what's it about? It's really about creating decentralized markets, right? How do you mutualize data? How do you mutualize facts? How do you mutualize processes? And don't build data silos in a trustless manner as much as possible, even though the trust is a tricky word here, right? So this is how I like to think about that. This is why this is important. Now, obviously, when you start building the systems, I would actually discourage you building decentralized systems, first of all, because they're hard to do. And you should always ask yourself, is that the right tool set to realize this particular system? And we came up with this set of questions, like a very simple set of questions that actually get you in the right set of mind to think about. Is this a good use case to be supported by something like blockchain or DLT or not? So you should start thinking, okay, is there a network? Well, do I need to have guarantees about my data? Am I going to share it or not? And if I do, is there consequences if my data is not correct? So some of the things you already heard about today, okay? So how do you guarantee that you're not misidentifying somebody and things like that? So, and then you can basically avoid doing a pointless blockchain project because it will, end up in tears. You don't want to do that. But if it's a good case, really pursue that. So, at the same time, what do you do next? Well, I think it doesn't matter which system you're building on top of blockchain or decentralized ledger, you should sort of think about layers instead of, ask yourself a set of business questions. Okay, so first of all, start with communications, right? So what entities actually create transactions? Like who should be part of your network, right? because you cannot build blockchain application just for yourself. Obviously, if you're building on top of public blockchain, that's easy, right? People hopefully will come. But if you're building some sort of a consortium blockchain and enable some sort of a market for enterprises, well, who do you need to build it with, right? Then, of course, you talk about, well, what are you exchanging? What type of information? Okay, is it monetary transactions, information about the state of contract, insurance, and so on and so forth? So that's important. But the hardest thing actually is a consensus. It's both very hard from computer science standpoint. We just heard earlier today from Jason that, hey, it's very difficult to build scalable, decentralized systems precisely because of communications issues and voting and all this, computer sciencey things that go on in there. But it's also very hard from business standpoint because if you start thinking through, especially complex use cases such as healthcare, insurance, other things that touch upon identity, all of a sudden you realize, well, you know what? I'm actually sharing some private data across a bunch of different people, and that's going to be there pretty much forever. So what do I do with that, right? So that's part of consensus as well. Who is allowed to see certain type of data and make decisions if that's the right set of data to share and put in history? And then finally, of course, well, this is, I think, the killer aspect of decentralized system. You can mutualize some business processes in form of code that's going to automate this process and make sure that everybody sees and does the same thing. So this is a framework that was actually created by David Birch, and I really like and I really apply it to most of the conversations we have with our customers or startups and everybody else. So now what about identity? Now I haven't talked about hopefully removing some of the mysticism from the world of decentralized ledgers. So what can we do with identity? And I think that it's important then, identity is a very, very complex topic because, it's very difficult to get people to agree what identity actually is. Now we seem to converge in the notion that identity is use case specific and it's all about attributes of my identity, maybe proving relationship, maybe proving over a certain age, I have ownership of something and so on and so forth. So it's actually, a fairly rich data set that exists pretty much for every application. So in most cases, actually, a lot of applications are related to identity, and some of them are real identity applications. And I like to categorize them in two different buckets. One is applications that are kind of identity as a key. In other words, I need to prove that I'm a member of a certain, hotel policy, so I get certain benefits. Or I'm a member of enterprise, so I get access to my office. Or I own something so I can use it, and so on and so forth. So that's basically identity as a key applications. There's a bunch of those, right? Now, the other applications that you have, I would categorize identity as content, where you actually, when you build applications, you have to deal with identity itself. So you have to change the state of identity. So for example, when you talk about buying and selling property or buying and selling cars, you have identity of property, you have identity of a car. And for example, when you buy a car, especially second-hand car, and when you want to get a deal for it, when you get insurance for it, you want to make sure that people actually has taken proper care of that car and it's legitimately sold to you. So it has to do a lot of that identity, but also with identity of individual that's selling it to you, people that service it, people that manufacture it, and so on and so forth. So identity is core to that application, right? And these applications are really, really hard. So how should you deal with those applications? I think it's important not to reinvent the wheel. Essentially, I mean, of course, in the early days you have to, but as things progress, and we heard from Jason the wonderful work that they're doing, actually they're also members of Decentralized Identity Foundation that counts people, like Microsoft there, IOTA, Uport, and many, many others that are really thinking about this, right? This is the pillars that they're addressing. Decentralized identities anchored by blockchain IDs linked to zero trust data stores that are universally discoverable for people, organizations, apps, and devices, right? So they're bringing all their intellectual capacity together from different backgrounds, different blockchain technologies, different use cases to really sort of, what are the common themes, what are the common standards we can leverage to build the foundations for us to build these applications. So that's very important. So what do they do? Well, one of the key enabling blocks, of course, when we talk about identity, is to have the actual object, right? Hopefully, we have some software developers here. They'll really appreciate this. Well, what are the identifiers, right? So And for decentralized identifiers, of course, it makes sense to have decentralized identifiers. And the design goals that went into designing these things, of course, is decentralization is one, privacy, how do you not correlate it, how do you discover them, how do you extend them. It should be simple, interoperable, and so on and so forth, right? And these are really, really important things. And fortunately enough, it was, I think, fairly straightforward, because when you read the standard that's published on W3C website, and it's work in progress, you see that's actually straightforward. So it starts with a very simple notion that you have a URI, essentially, which has a DID as a prefix. Then it has a method, we'll talk about what that is, and then the actual identifier, right? So that's a very simple string, you always start with that. So then, of course, well, what's behind it? What's behind it, of course, is a JSON document, or JSON LD document to be precise, which then talks about various things connected to that identifier, such as, the type of key, the verification key, it can be a biometric template that's a work in progress, and a bunch of other properties that talk about the endpoints, like where do you reach the agents if there are agents behind it, and what other types of services are connected to that identifier. So I think that's very powerful, because if it's interoperable, extensible, you can start building applications today that are going to be future-proof, right, and not going to take you to a dead end, because we are dealing with generation 1 technology. Things will advance, things will change, but you want to build applications today, so it's important to start using some standards as they become available. Now, the great thing about that, of course, is that this is not just one dominating player. There are actually multiple technologies, including Bitcoin as an anchor to store these identifiers and documents that describe the identifiers. And there's now a functioning prototype that you can contribute to, which has a very simple architecture, right? With Docker technology, you can just package, download it, put it up, and using simple HTTP query, basically turn the identifier into, query the backend that behind it, and get the object that corresponds to the identifier talking to the backend that might have been designed with completely different ideas in mind. So, it's already very, very practical, and I encourage you to use it, but also contribute as well, right? It's on GitHub, well-defined, so you can use that. And the things that work with it today include Uport, Sovereign, Blockstack, Veris1, and even things on just on IPFS as well. But it's you can add other things as things progress. Even Ethereum naming system is supported in theory. So that's a very cool piece of technology, very practical. So let's talk about some applications. So I'll give you a couple examples of applications that I think of identity as a key type of applications. So obviously, people try to standardize verifiable claims, right? DIDs is fine, but, well, what do I do with that? Well, one thing I can do some attestations, right? So, and W3C, again, has a working group that's trying to standardize the space, and one example is like here. So this is the claim, a verifiable claim. As you can see, there's some information about who issued it, and this is an American example. DMV is somebody who issues you the driver license, also the plates for the vehicle, and so on and so forth. So the claim is basically age over 21, and it's good for this identifier. Now, you will see that this method is just an example. It could be Sovereign, it could be Uport, it could be other different things. So you can go to this URL and verify that it's still valid or not, right? And here's the signature that you know that this has not been tampered with, right? So, and it's very simple. And there's a language that talk about that. So basically, you have an issuer that creates this claim, right, for the holder or the subject of this claim that has an ID. So this person will receive that claim from an issuer and then can present it to a car rental, say, hey, I'm over 21, I'm allowed to drive this fancy car, right? So very, very simple use case. There's lots of use cases like that, and you can already actually see how the standard is supporting that, right? But let's take it a step further. And talk about how things actually done in a more complex way, because as you've seen probably, if you look at that JSON document, well, there's not much you can do with it besides proving the attestation. Hey, somebody who is respectable tells you that I have certain attributes, right? So that's good. But what if you actually had different identities in different scenarios and wanted to combine those? Now you have self-sovereign identity, because that combines your various parts of your identity, your professional life, your personal life, community life, and so on and so forth, for different purposes. So the use case here that we actually have been working on is a corporate travel use case. So typically, when you deal with hotel chains, the problem is that you go to the internet, say, okay, I'm going to Hague, who has the best rate for, Hilton here, it's IBM, great, what's their code? I just go and use it and rent a room using IBM rate, and they have basically no way to challenge you, they just don't bother. But it causes some issues, actually, within the system. So how to prevent that? Well, actually, a company then becomes a trust anchor, which gives me claim that I'm authorized, okay? And I have an identity that I use for this specific relationship. I then go to hotel and I provide a proof to them, right? Not just provide the claim so they can verify it. Actually, I provide the proof to them because what's not shown here, behind here is a sovereign ledger that allows you to have this pairwise identities and do the proofs and claims, because every claim has a schema that's actually stored on that. So basically, then the company has a traveler. We know that there's a claim that corresponds to authorized travel type of claim, right? So the hotel can then ask me for a proof. I will use that claim to create that proof, and I'll use a different identity here if I wanted to, for example, right? Maybe corporate travel will use the same identity, but if, for example, I was checking in as a private person, I would use maybe a different identity so they cannot track me across my different interactions, right? So this is how I'm already moving beyond just verifiable claim into the situation where, okay, I'm building my identity depending on my use case. Now, okay, so as I stay in different hotels for the company and save them money, obviously I also want to use the points that I get from that, right? So now I wanted to use that points to maybe pay for a rental car, right? Which is completely different relationship altogether. And then it means that I can combine identity about who I am, maybe from another office or authority, with information coming from hotel about my points that I have, to provide it to the car rental agency so that they can verify it without actually knowing who I am and talking to either hotel or the company, but using the ledger that's kind of invisible here to do that, right? So, and there's actually fancy crypto that goes on behind the lines. You can see some of the things here. So there's some secret keys, identity of the schema, and zero-knowledge proofs that happen behind the scene that allow you to take one relationship, another relationship, combine it, and build another relationship, right? This is how things become when you are able to share the attestations, attributes of your identity selectively, right? So that's a very powerful use case. But that's still identity as a key type of use case, right? Now, so what about some more complex applications? So when we start actually to deal with identity itself, when we need to propagate this identity and build some trust on elements of that identity, and in this case, that was counterfeiting example. So like obviously those are very, very hard applications and very, very common problem in supply chains, be it medical supply chain, luxury goods or what have you, or just foods in case of China, for example, and some other places. So one way to address that is to look at chain of custody. Obviously, I cannot tell you that this is a universal solution for everything. It also depends on type of packaging you're sending. But basically, what you can do as a pattern, right, as an approach to this, you can start with building chain of trust, right? So the manufacturer will basically start using identifiers to create claims for a chain of suppliers. You can have a hierarchy of the chain of suppliers and users that will know that they all authorized by the manufacturer to deal with the goods, use the goods, administer the goods, right, transport the goods, right? And of course, you deal with maybe the regional carrier, shipper, then you have other layers of shippers to the local shippers, and maybe the chain of trust goes back, right? So you build a chain of trust so everybody can come and say, yeah, I'm actually authorized to handle this. Then in the next step, basically the manufacturer produces a package. Package has an identity, right? Hopefully, and depending on the application, of course, you might protect the package with some tamper-proof electronic identity type of things or other means so that people cannot easily replace the packaging content or replace it itself, right? So, but that's a parallel problem. Now, as you start moving that package around, so what you essentially do, you then create the claims between different parts of your supply chain where you basically, so manufacturer creates a claim, they produce the package, and they also produce the claim for the first shipper that they gave it to that shipper. The shipper then gives another claim back to the manufacturer, say they have verified and accepted it. So now they move it to another point, they hand it off, another exchange of claims happens, right? And so on until it reaches the clinic. At that point in time, I'm getting the latest claim or a set of claims, and then I go back to manufacturer and say, well, does that match your history that you see, right? And here we have ultimate flexibility. We can do it with the DLT in the middle, and then of course things become a bit simpler, so you can just record the facts that this exchange has happened. Or we can do it without any connectivity technology altogether, just by the fact that we have relationships, we know who these people are, and then and I ask the manufacturer goes back and says, okay, can you check where this been? Tell me, give me the trace, give me the trace, give me the trace, give me the trace. And then basically I have my chain of custody, and because I know who these people are, I can say, okay, this actually package came in intact, I know who handled it, where it's been, right? So I have ultimate flexibility, even if it goes to countries where the communications are probably not as designed, I can still use electronic technology using very simple applications and basic computations with apps and so on and so forth, right? So this is one way to do it, and gives you actually very nice power where you're using a combination of physical interactions and zero knowledge proofs and crypto to create a chain of custody to create that application. So now we're coming to, I guess, the most complex part of designing applications. And these are the applications where you use identity as content, but you want to use DLT, right? So we talked about some of this, like, for example, and the reason why you want to do that, I would call them orchestration use cases. So healthcare is a good example. So now one of the interesting use cases that people talk to us about is this. Pharma manufacturers typically, when they manufacture drugs, they don't deal with the patients, right? They deal with wholesale holders, they deal with other intermediaries, but never with the end patients, right? So their systems are not built to deal with the patients. Now, of course, because of personalized medicine and advanced technologies, for leukemia, for example, there is a process whereby you can collect blood cells from a patient using something called apheresis center. It's a very invasive procedure, usually done for very, very sick kids. So you collect the blood, you then send that blood to a special lab. Lab processes the blood, and they have a very special process how to make sure that they're not mixing that blood with somebody else's. Then they move it back to the treatment center. Treatment center takes it and then injects the blood back into the patient, and patient is cured, right? So here, the manufacturer all of a sudden has to deal with the specific person's material, which has a lot of privacy implications, health implications, customs implications, safety implications, and so on and so forth. So it would be good to orchestrate it using something like DLT or blockchain and smart contracts, because everybody sees the same data, they know exactly what happened, what needs to happen. The problem, unfortunately, is if you start doing that in a very straightforward way, you end up storing a lot of personal information here, right, which is difficult to erase, and it might create some leakage. So how to approach that? It's basically my advice, and we're still thinking about this. I don't think anybody has, out-of-the-box formula how to solve this problem. But the best way is to separate, right? In software development, I think separation of concerns is a great principle. It's been applied successfully for a long, long, long time. And this is what we advise to do here. Use DLT land to do exactly what it does best. Shared rules, shared state, rules driving the change of state, right? And then use other specialized ledgers, and in this case it's Sovereign because it does job quite well, I think, where you have your definitions and schemas, your DIDs, to handle exchange of information and properties and claims between the things and people, right? And then, but keep keep the personal information, keep specific information off the ledgers, right? So if it's a doctor, doctor will have specific information here. You know, the person will have their specific, payer will have their specific information, banks and auditors, they'll have their own specific information. But then you can use the ecosystems and these individual entities, basically keys, to share this information when needed, maybe off-chain, but orchestrate the process using the on-chain technology, right? So this is a very, very different pattern, and I think the challenge that everybody has is that when you think about decentralized system and you know the natural aspects of technology, to think differently, think outside the box, and embrace new technology, right? So to do it properly, okay? With that, I just wanted to do a quick summary. So I think that a lot of applications out there are actually identity applications. Now the legislation is becoming aware of that, so you have GDPR and other regulatory regimes that talk about PII, so your life is becoming hard when you build the systems. You actually have a lot of penalties and other things that might happen to you if you don't do it correctly. So, so that you need to address that well. And you really need to think about, well, how am I going to use a reliable identity? Because if it's not, well, the systems are not going to perform. And of course, when you think about identity, identity is more than just name and address and age. It's really all these different aspects of relationships, of business relationships, access to information, ownership rights, and so on and so forth, that you can actually use in an off-chain fashion like we just talked about, which I think is a really new way of doing things. And of course, it's, you know, like some of the customers like to say, blockchain is a team sport, so you have to engage with other people and play well, participate in different alliances, participate in ecosystems and share knowledge, contribute back, and, you know, make things great. So with that, that's my talk.
Thank you.